Hey there, viewers. Welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. smAsho. Today we've got some earthquakes to cover. And we'll also be talking about how the heliosphere is nothing like the galaxy. And we'll explain why in graphical detail. First thing we're going to do is look at the new sunspot, which may not be all that visible. It's right there. It has not completely degraded yet. It'll get a name today. Sunspot 2802. Otherwise, pretty low levels of activity. There is a coronal hole leading that sunspot, and you can see it in 304 angstroms right here. And there's also a filament in between the sunspot and the coronal hole. That's the coronal hole. There's the large filament. Several Earths in diameter in size. And we'll zoom out here to show you the full disk view in 304 angstroms. Some filaments in the northwest as well. Possibly another active region rising in the northeast. We'll show you more images. First, here's a diagram of the solar system. And there's where things will be in a week on February 16th. Here's a star chart. The ecliptic today goes through Virgo and Libra and Leo and Gemini. I use in-the-sky.org. If you want to make yourself a sky chart, just put in your location. And I ask you, the viewer, where were you when Cygnus rose? The 10.7 centimeter radial flux, back up to 74 solar flux units. That would be the radio output of the outer corona, which is the most known proportional measurement to sunspot number. So there's the context for that. It's the 1-year chart of the 10.7 centimeter radial flux, which would be the upper black line. Again, at 74 right now. And there is the radial flux through the last solar cycle. A little bit of a hiccup in the ramp up into solar cycle 25. So welcome to cycle 25. There's the sunspot number progression, and there is the radial flux graph. HelioViewer is down for the count. So here's another view from the SDO Browse Data page. It's the 171 angstroms. And we've got more views of the local yellow dwarf for you here, for all you stargazers out there. It's yet another edition of the Daily Space Weather here at the Smash News Network. Next thing we're going to look at is volcanoes. And it looks like Pacaya is back on the list. It's a report about the Ring of Fire. And thanks for leaving a comment, Kathy Garden. Good morning to you too. Here's the volcano rundown for today, February 9th. Ibico is erupting. It's producing a 7,000-foot plume of ash. Sakurajima exploding. 7,000-foot plume of ash there as well. Raung, it's an uptick at Raung on East Java. It's a flight level 180, an 18,000-foot ash plume. Tokono exploding. Flight level 060, a 6,000-foot ash plume there. Popocatépetl exploding. In central Mexico, flight level 190, a 19,000-foot ash plume. And Pacaya exploding. So down in Guatemala, Pacaya now back on the list. 11,000-foot ash plume over Pacaya, and Revenador is reminding us not to attempt to pole vault or tightrope walk the caldera via exploding and producing a 16,000-foot plume of volcanic ash. And here's the earthquakes around the Ring of Fire we cited in the title of today's video, and you can see earthquakes all around the Pacific Rim, although no large ones. And the 7, 8, and 9 magnitude earthquake drought continues, folks. A very low number of large earthquakes over the past, indeed, couple of years. So it looks like some quakes in the 5 magnitude range. A deep quake strikes Fiji at 4.6 magnitude and over 620 kilometers depth. A 5.1 strikes Japan. A 5.4 strikes Taiwan. 5.1 at Tonga, 5.1 at depth in western South America there, at Peru, a 5.0 south of the Philippines, actually within the archipelago, another 5.0 north of the previous one we reported at Peru. Looks like the largest of the past 24 was this 5.5 at Papua New Guinea. Another 5.0 strikes Japan. Some Cascadia quakes there, small magnitude. Some quakes around Yellowstone. A 5.2 at Japan, a 5.2 at the Bandai Sea at 170 kilometers depth. And that's today's earthquake report. I would invite all of our viewers to check out our own websites at smashomash.org, which will redirect you to smashomash.com. Why? Because we're using the proceeds to fund our nonprofit organization, which we haven't even filed the paperwork for because, frankly, we can't afford it yet. So please consider getting involved. You can visit all of our social media links to our Patreon, our PayPal, etc. And you may want to pick up some merch. Check out our forum. You can link to all of that from the homepage, again, smashomash.com. And today's official endorsement is the merch site, the newest one at Redbubble. It's redbubble.com/people/smashomash if you want to go directly. It's easier to just link from our homepage, probably, than typing all of those characters, especially on your smartphone. So today's featured product is the Google Bias product. And there are a whole bunch of different products there. You can get a series of different shirts, stickers, iPad skins, phone cases, framed art prints, coasters, pins, tote bags, water bottles, mugs, etc. And the design is talking about Google Bias, because we prefer not to use Google as a verb, since the verb's definition is to obtain biased search results by using the Google search engine. To obtain biased information about someone or something on the World Wide Web, to use it in a sentence, I Googled it, and now I know less about it. And I own one of these shirts in red, and by the way, the print quality is pretty epic. It's also got our website at the bottom, so check that out. Again, you can link to all of that at our homepage, smashomash.com. Two other designs there. You'll have to find out about those yourself. Did you watch yesterday's Daily Space Weather Supplemental? It's entitled Daily Space Weather Supplemental. It's Sunspot 2802. It's got some original music on it. And we've got some extreme close-ups of that filament. There's the 304 angstroms portion of it in slow-mo toward the end of the video if you haven't checked that out. You can find all of our playlists at youtube.com/smashomash/playlists. And if you enjoy the content, don't forget to press like and subscribe. Please share the content in your social media. We need your help to grow the channel, as we can't seem to rely on algorithms. For some reason, not particularly recommended by the junkware algorithms on YouTube. Thanks again to all of our subscribers, our loyal old subscribers, as well as our new subscribers. Cheers. Thanks for tuning in. We'll wait while you press like and subscribe if you're new here. Press the notification bell, press share on your social media. Wherever you happen to be, we're probably there as well. And thanks for everybody who does. Yesterday we made a BitChute exclusive, so make sure you check us out on bitchute.com/smashomash as well. Yesterday's BitChute exclusive, not available here on YouTube. And I didn't say anything particularly edgy, but go have a look if you haven't yet. Today's smAsho stream was streamed live at twitch.tv/smashomash. Thanks to our new followers over there. Twitch.tv is a great streaming platform. Twitch.tv/smashomash. Next, I'd like to thank our patrons, the real source of funding for the content, the main source of funding for the content, as we make just this side of nothing to put these videos on YouTube. So thanks to our patrons. Cheers. It's patreon.com/smashomash. And there are various different tiers there, starting at $3 and ending at $15 per month. This is the new credit crawl. So thanks to our new patrons, and patrons are listed in order of lifetime contribution, and only active patrons are listed. Again, it's patreon.com/smAsho if you want the earliest warnings, alerts, ringtones, music, etc. Patreon.com/smAsho. And let's do a cosmology segment. As yesterday we spoke briefly about Sagittarius X3, which is a high-mass X-ray binary. Today we're going to roll a random number, but first we're going to talk about how the heliosphere is nothing like the galaxy. So, right now I'm on plasmascape.com. On plasmascape.com you can create this, which is a 3D viewable solar system. And there are different zoom levels. So the first thing I would invite you to do is press the A button, which will bring out all the tabs. And what you see here is the inner planets. So as our regular viewers are well aware, the sun is constantly putting out this spiral known as the heliospheric current sheet. And it's got different polarity portions of it as the solar wind comes out. The two solar polar fields, they orient portions of the current sheet to their polarity. And the Earth is constantly passing through into north and south pole oriented current sheets. And so the sun is rather directly interacting with the Earth as it spews out particles. When the particles get to the magnetosphere, they create induction. As the magnetosphere causes them to break, it's a thing called Bremsstrahlung, which means the breaking energy of those protons striking the magnetosphere and causing all kinds of chemical reactions and so on. So the sun is constantly putting out this heliospheric current sheet. We call it the Parker spiral. And it's always blasting that out as it gets more and more diffuse as it heads out through the solar system. And this spiral of protons creates induction in the Earth's geospace. This is why we show the geospace movies daily, because it gives us a graphical analysis of what's going on in the geospace. So if we zoom out, you'll be able to see the tabs that we've created by pressing the A button. So you see that A button, there's a tab pointing toward the North Galactic Pole. The solar apex, that is the direction that the sun is moving with respect to the local stars. So if you zoom all the way out to number 5, this is going to show you what we call the local chimney. So the local chimney is a structure within the Milky Way galaxy. It's like a tube of denser dust that's kind of hollow in the middle, and the sun and the local stars are sort of moving through that local chimney. So it's a sort of an hourglass-shaped thing, and we get the data on this by looking at stars inside and outside the local chimney and seeing this distortion created by this dust in between us and those other stars. So, you can see the solar apex. There's the direction that the sun is moving with respect to other stars within the local chimney. However, the entire local chimney is moving toward Cygnus. So this is Cygnus someplace over here. So this entire structure is actually moving in this sort of a direction. And the sun, with respect to other stars, is sort of moving in this direction at an angle to the galactic core. Really, it has nothing to do with the galactic core. And so let's zoom in a little bit closer here so we get the constellations back. We'll go to level 2 here, which is the second closest. Let's go to level 3. So there, that sphere that just zoomed out, that's the heliosphere. So now, if we orient this 3D image here towards Cygnus, you can see the star Deneb right there. So there's an indication of the real motion of the sun. So the entire local chimney is moving in that direction. It would be moving away from us from this perspective toward Deneb. However, the sun is moving in this direction in relation to that. So it's at basically a 90-degree angle to the motion of the entire local chimney. And that, folks, is why the heliosphere is nothing at all like the local environment. Stars interact with each other, but the sun is not interacting with the galactic core. Yes, we do receive X-rays, we see infrared radiation from the galactic core, but there is no direct relationship between the galactic core, which is why all this nonsense about the heliospheric current sheet is just that. Total, complete, and utter nonsense. If you want to look at this stuff yourself, head to plasmascape.com, and you can load that up yourself and check it out. Now we're going to look at a random object here. We're going to pick a random number between 1 and 1031. Today's random number is 148. So we're going to go to the Neil Gorell Swift Burst Alert Telescope, and we're going to scroll down to number 148 and see what we have. This is PKS 0447-439, a BL Lacertae. So that is a type of galaxy that has sort of a broad band of emission spectra. Here's the X-ray portion of the electromagnetic spectrum that we see from galaxy PKS 0447-439. And you can see it's a pretty consistent X-ray source. This graph is actually pretty similar to the X-ray graph from Sagittarius A star. And let's see if we can get some imagery. We should get some good images of galaxy PKS 0447-439. So we'll go take a look at it on Aladdin Light here. Again, a BL Lacertae type object is a type of galaxy that shows us a broad band. So this galaxy should show up in all kinds of different emission spectra. Not just X-ray, but also infrared, visible light, etc. For some reason, the layers are not showing up here. It's the dangers of streaming live, folks. I don't know why we're not seeing anything here. Perhaps there's maintenance going on these sites as well, as we're not able to bring out other layers. Can we see the 2 mass? It doesn't look like it. So perhaps this website is under maintenance as well. At least there are the X-ray transients from the Neil Gorell's Swift Burst Alert Telescope. If you want to follow your favorite transients there, like say, oh, I don't know, Sagittarius A star, right? There's Sagittarius A star. There are the X-ray transients from the core of the Milky Way galaxy, the massive radio source at the Milky Way galaxy. And again, the idea that the structure of the Milky Way galaxy is as simple as the structure of the heliosphere is complete ridiculous nonsense. And our regular viewers may know exactly who I'm talking about. That person and channel shall remain unnamed in today's cosmology segment. Let's get back to data. Here is the GOES X-ray flux, and we don't see any solar flares here, despite that new sunspot. It's a pretty weak sunspot. It's quite small, and I think it's only alpha class. We'll let you know by the end of the video if it's alpha class or not. We don't see any proton strikes. There's the 3-day chart of the GOES proton flux. As protons are the main component of the solar wind, and indeed also cosmic rays. And don't get the two confused. When we're talking about cosmic rays, we're not talking about solar protons. Cosmic rays are protons coming from outside the solar system. So although solar protons have a similar characteristic to cosmic rays, when we refer to cosmic rays, we're referring to more distant ones, ones that are from within or even outside of the Milky Way galaxy. And one of the only known point sources would be Cygnus X3, the star Deneb, which coincidentally the sun and all of the local stars in the local group and the local chimney are moving toward. Next, looking at the real-time solar wind, to see the phi angle's been shifting around here over the past 12 hours quite a bit. And we're going to see a pretty significant coronal hole wind stream from the large coronal hole that's leading sunspot 2802. Give it about 4 days. Current solar wind density, about 6 protons per cubic centimeter. Current solar wind speed slightly elevated here at 500 kilometers per second. And that's not enough to bring the KP up any higher than 2. So the KP index is a measurement of global geomagnetism. There's a 3-day chart. You can see that brief geomagnetic storm for 3 to 6 hours on February 7th. Next, looking at geospace magnetosphere movies, it's 4 hours of data. We're looking at magnetohydrodynamic pressure here. And from this perspective, the sun will be off to your left. You're looking at 2 90-degree tilted images here. So one will be as if you're looking down at the pole of the Earth. That would be the left, the equatorial plane. And the other would be looking at the side of the Earth, the meridional plane. And you can see the majority of the pressure at the beginning of the movie here is in the magnetotail on the right of your image. That is where the protons are accelerated back into the solar wind. They're reintegrated as they skim past the magnetosphere. Next, looking at perturbations on the ground, changes in the Earth's own B field. We show it daily since we're in a magnetic excursion. And we do see some perturbations here by those induced protons coming in at 500 kilometers per second. We won't translate it into miles per hour, but let's just say it's pretty fast. Hundreds of thousands of miles per hour. Next, looking at the GOES magnetometer. And we see some spiky readings here for you new viewers. The N's and M's are midnight and local time. Midnight and noon local time, that is, for the GOES 16, where the magnetometer makes its measurements. We're seeing pretty quiet readings here. And I just wanted to also note one more thing. The hydrogen alpha images that we showed yesterday, because the SDO and the SOHO were both down, you can find these yourself at the National Sunspot Observatory. If you type in NSO space GONG 2, you'll be able to find this. And I'm just going to show a quick hydrogen alpha video here. This one from El Teide. So in this image, you're looking at the emission spectra of hydrogen, since that's the primary chemical on the sun. This is 6,562.8 angstroms, one of the emission spectral lines of hydrogen. And you can see a great image of that filament as well as that active region, sunspot 2802. Next, we're going to look at the heliosphere, which again is nothing like the structure of the galaxy at all. The galaxy is much more complex, as you're not really interacting with the core of the galaxy, folks. Sorry, it's just true. Now, this data is pretty old. It's nearly 4 hours old. And the Earth is solidly in the South Pole current sheet. I would not expect it to change, although if that sunspot suddenly grows, that could change things. The magnetic environment can suddenly change. Again, this is 4 hour old data here. So this is showing the sun's B field. It's a line of sight field plot. Next, we're going to show the coronal hole field plot. And there you can see that large red coronal hole in the south there, just moving into the Earth-facing zone here at the end of the movie. That will provide a significant geo-effective solar wind, probably a small geomagnetic storm once again. And here is the magnetic field plot of the solar corona, the sun's atmosphere. A chaotic place indeed. This shows you closed potential field surface source lines in pink and open ones in black or purple, depending on their location. Polar coronal holes shown in black. Non-polar coronal holes shown in purple. And here's me vanishing. It's a diagram of the atmosphere shown in kilometers. And we show it daily because this is where the GOES 16, where a lot of the data we use, gets its measurements, around 300 kilometers altitude. Here's another diagram showing you the Van Allen belts. This one is in miles. Pause it if you need to look. We'll be here when you get back. It's the beauty of video on demand. So here is Yeah, it's a charging hazards visualization. And we see some minor charging hazards here over Central America and Mexico, despite having pretty low levels of electron flux. And there you can see the 3-day chart. Pretty low levels there. Here's a 1-day chart from Solon.info to put it in context. Pretty much in a moderate portion of the range. Here's a visualization. This will show you where GPS errors are, which primarily happen around the equator at noontime. It's the total electron content forecast. Here's the relativistic electron forecast model. And you can see here the forecast is for an uptick in 2 days. I have no comment. I'm not going to try to forecast electrons this time, as there's a lot of stuff going on. Coronal hole wind streams and so on. Next, looking at the ionosphere. And this is approximately where the GOES 16 is making its measurements. Ionosphere looking pretty normal to me. Here's the latest image coming in at 9:15 Universal Time. Next, nullschool.net. We've got this system over the southern Indian Ocean once again. Still producing pretty strong winds. I see some red there. Pretty desolate place there, the south central Indian Ocean. Not a lot of people on boats down there, most likely. Anyway, here are the jet streams, and look at the extreme chaotic jet stream flow in the southern hemisphere. It's all over the place. Oh my God. Doubled up jet streams in the northern hemisphere, as well as meridional jet stream flow. When you see the jet stream moving north and south, that's not the regular jet stream motion. Here are the jets of the Western world, and also once again very chaotic. We have an upper level low pressure system right here, practically right over the South Atlantic anomaly. As well as extreme meridional jet stream flow. Look at this, it's going northwest over northeastern Canada. Coming down here, crossing the equator. Extreme meridional jet stream flow at its finest, folks. And this is the cause for most of your weird Earth weather. These jet streams being this far out of phase. And let me just check the life of the stream. Thanks again for leaving comments, Kathy Garden. We like doing explanations because we prefer to promote facts and debunk frauds. You know, just the good old smash, never meaning no harm. All right, so here is the windy.com pressure map scenario. Look at the high pressure still dominating the entire northern hemisphere, especially the polar region. Check out these giant high pressure zones. Major high pressure zones up there, and low pressure zones dominating Antarctica. We're going to advance this till tomorrow. There's where we expect pressure to be tomorrow at noon Eastern time. And if you're wondering where we're located, Smash staff and I, and thanks again patrons, are located in eastern Pennsylvania, right about here in the Lehigh Valley. So here's the U.S. Doppler radar map, and we're getting some heavy bands of snow rolling right over me. And wish me luck today. I'll be driving through some of the worst conditions in Pennsylvania today. I'll have four-wheel drive when I'm at work. Let's hope I'm able to get home from work. I will request using the work truck if it is too bad to make it home in the regular vehicle. Some thunderstorms there looking like they're kicking up over the southeast. Let's check lightningmaps.org for a real-time lightning map. As we've removed the lightning section, but now it's back because we've got thunderstorms over places like Alabama. Hey, Montgomery, there's thunder rolling in. And you can use lightningmaps.org to actually forecast thunder. You can see that thunderclap propagating there. Convince your foes that you're Thor or perhaps Odin with lightningmaps.org. Here's the Tropical Tidbits total snow forecast. And that is through Thursday at 12 o'clock Universal Time, a.k.a. 7 a.m. Eastern Time. There's how we expect that to play out. According to the GFS forecast. Here's what's going on in the cloud layer. It's too dark to see the clouds, so we use the NASA GOES shortwave radiation map. Here's what's going on in the water vapor. And you see all that moisture over eastern Ohio moving into Pennsylvania and New York. And that moisture in the southeast is being contained by this dry mass of air right here. This dry mass of air creating a physical barrier, preventing this from going north and creating pressure gradients and precipitation. Lots of moisture over the southwestern U.S. as well. And a little band of dry air moving across southern Illinois. So clear skies will move across southern Indiana and southern Ohio throughout the day today. And when you see this dry air like that, you can expect to see clear skies. And not promoting fraud creates clear skies, in my opinion. Thanks for promoting fraud by watching the videos, Smash Team. Please visit our links, support the channel. Press like and subscribe on YouTube if you enjoy the content. Share with your friends, your foes, your science noobs, your science pros, and whoever else may be interested in the content. Press the notification bell, etc. And stay tuned for bonus features. We've got a couple of them. It'll be the high-res image of Sunspot 2802. So here's the most recent intensity gram, and it is indeed degrading. You can barely even see an umbra there. It looks like it's going to evaporate. If I had to guess, I'd say it's going to be gone soon. So there's a colorized magnetogram, looking weak. There is the intensity gram. That's barely an umbra, although it should get named, as it's certainly been there more than 12 hours. Last thing we'll do is we're going to show you a 193 angstroms video and a composite, including the colorized magnetogram and the 171 angstroms wavelength. And allow me to vanish. So thanks for tuning in, folks. There's 193 angstroms. All eyes on that filament in the southeast. Another coronal hole emerging in the northeast as well, as one sets around the equator. And here's the colorized magnetogram and 171 angstroms video from the SDO Browse Data section. Thanks for tuning in, folks. Let's zoom in on that filamentary area and sunspot 2802. That's about 1 day worth of data, and we are out. Thanks again for tuning in. Remember, stare at the sun. Welcome to the Neo-Renaissance. Visit our links. And when you are staring at the sun, don't drink. But if you do drink, don't drive. Seriously, don't drive. And since it'll never be now again, may that solar wind be at your back.